Cool, that looks good to me. So let's check out day 3. I've got I'm using REPL.it, and I'm going to make a new, how do I do this? Make a new REPL Python. I'm just going to call it day 3. So this is where I'm going to be writing my code for today. So I'll send that in the, oh no, I'm not logged into my Twitch chat. Maybe I won't send it in the Twitch chat today, but it'll be in the bottom of the YouTube video as well. Oh wait, I can send it here. There we go. I'm logged in here, I'll do that. Okay, apologies. Like I say, I'm using some new software today, so it's things are a little bit different. But yeah, let's get on with it. So, challenge 3, Toboggan trajectory. With the Toboggan login problems resolved, you set off towards the airport. While travel by toboggan might be easy, it's certainly not safe. There's very minimal steering and the area is covered in trees. You'll need to see which angles will take you near the fewest trees. Due to the local geology, trees in this area only grow on exact integer coordinates in a grid. You make a map, which will be your puzzle input, of the open squares, denoted with dots, and trees, you can see denoted with hashtags. Oh my gosh. Nightmare. Okay, let's see what. That's our puzzle input. Great. I'm feeling much less confident about this one, but let's see. These aren't the only trees, though. Due to something you read about once involving arboreal genetics and biome stability, the same pattern repeats to the right many times. Okay. Okay. You start on the open square. The open square. It's not clear which one that is. I'm guessing it's this top left one, but we'll see. Oh yeah, in the top left corner, you need to reach the bottom, below the bottommost row of my map. The toboggan can only follow a few specific slopes. You opted for a cheaper model that prefers rational numbers. Start by counting all the trees you would encounter on the slope. Right 3, down 1. From your starting position at the top left, check the position that is right 3 and down 1. So it's empty. And then check the position that is right 3 and down 1 from there, and so on until you go past the bottom of the map. The locations you check in the above example are marked here with a circle where they were free and an X where there was a tree. In this example, traversing the map using this slope would cause you to encounter 7 trees. Starting at the top left corner of your map and following the slope of right 3 and down 1, how many trees would you encounter? Okay. So we've got to basically figure out a way of reading this into something, navigating down through it until we get to the end and counting how many trees we hit. Doesn't look particularly easy, but there might be some stuff we can do to make it a bit easy. So test input. Gosh, you know, I've got no idea how to start with this one. I think this might be the first one you don't finish, but let's see. And dots are free, hashtag is a tree, and we're looking to get 7 for the input of a slope, right 3, right 3, down 1, tree 7. Okay. So again, didn't say it today, but I'm aiming this at people who have almost never coded before, or who haven't coded in a long time, or who've sort of done, 5 hours of something like Code Academy or Data Camp, and you're sort of not really sure what to do now that you know Python or some other similar language. So I'm using REPL.it, which lets you spin up sort of a dev environment for various languages. And in that, it's got loads of helpers that you'd get in a normal, well, sort of a solid text editor. So stuff like pressing Control and / will comment and uncomment stuff. So that's all I'm doing here. So these are just comments. So when I press play, nothing happens, because all I've done is basically write these notes along the top. Okay, So what I need to do really is read this into some sort of list, I suppose. So I could, yeah, what I'm thinking is if I read this into a list, I can use something called Modulo to sort of loop around within the list. Seems nice. So Modulo is a weird one. So we've talked before about the basic sort of math stuff. So we can do add, take away, we can multiply stuff using the asterisk, we can divide stuff using a forward slash. There's something used quite frequently in programming called a modular operator, which is the percentage sign. And what this does is it returns the remainder of division. So if we do 10 divided by 5, for example, the remainder would be 0, so we return 0. If we do 10 divided by, I guess let's do 9. So if we divide it by 9, there's 1 9 there with a remainder of 1, so it returns 1. So this is really useful for stuff like checking if a number is even. So you could use like a for loop to count over the numbers for number in range 10, and we could print number modulo 2. So this will go over each number, and it'll just say what the remainder is. And we can basically use that to say which numbers are even, which numbers are odd. Where that applies here is that each one of these individual lines has a certain number of cells, elements, yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's not the same in here, so we can't just trust that, but because, as they've said, it repeats sort of infinitely, which means that we kind of need to assume that this continues like that forever. So we can do that with modulo to basically, say that the first position is equivalent to the 12th position, which it is. Or we could say the position modulo 11 is always the same. I'll probably show why that's correct with a simple function, because that might be a good way to actually get started. So to start with, let's just have a look at this first row. So I'm going to put it in a list. No, I'm not. I'm going to put it in internet trees, in a list, and I'm going to have it as a string like that. I guess for now, let's just have it as a string. So that's our trees for now, and we want to access the position. Gosh. Okay, so if we get, what we basically want to do is say that I want to show that, so trees 0 is equal to trees 11, no, 12, modulo 11. That's not going to work, is it? 11, 12 modulo 12. Let me check that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So is that going to work? I probably need to do it. Okay, that's correct, but that could be a coincidence. So let's do something that sort of counts up to 10, or counts up to the length 11 for number in range 11. And then I'm tab indenting here, print number. So all I'm going to do here is try and print the numbers up to 11, which I've not done, 12. But these are our indexes for these positions, right? So we've got the 0th position, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th. Yep, so that'll work. So I'm going to print the number, which is actually, let's call it index, because that's what it actually is. Index. Then I'm going to print the tree at that index on the same line. And then I'm going to print the trees modulo 12, just to make sure they're all the same. That's not good. They're not the same, because I'm not using my index. So it should be index modulo 12. Okay, So let's slow down a bit there because I've done a huge amount of weird stuff there. So to start with, trees is one of our variables. So in Python, you write and assign that variable just with a name, and then an equal sign means kind of is assigned to. So we're going to assign this string to the variable named trees. So now whenever we call trees, we'll receive that value. So in this case, it's a string, and that's denoted with those quotes. My sort of example for variables is if you were sort of packing up your kitchen, you'd put all of your kitchen things in a box and you'd probably write kitchen on the side. And then from that point on, you'd probably refer to it just as the kitchen box or something like that. So that kitchen box is kind of a variable name, and the data that variable stores is the things inside the box. So here we've got a variable called trees, and I can say, show me what's in trees. And, you know, we can access it, we can check it, we can move it around, we can do whatever we want. But we don't actually, you know, we don't refer to it as, oh, give me that string that's got 2 ellipses followed by 2 hashtags followed by 8 more ellipses. That's kind of silly. So variables are a really useful way to sort of break down code into more human readable stuff instead of just doing loads of magic and sort of trusting that people know what's going on. So yeah, that's that one. Then the next one, this for loop. So again, not really explained any of this. So a for loop is basically, it lets you loop over the next line of code multiple times. So anything that's indented in here with a tab key or 2 spaces, anything that's in there will run as many times as this for loop tells it to. So in this case, for index in range 11 will iterate over the numbers 0, 1, 2, 3, all the way up to 10, and it'll print out some stuff that I told it to print out, basically. We have to use a colon there. You have to have this tab indentation, otherwise it won't work. And this range is sort of a shortcut just to get some sort of plain English numbers. We could do all sorts of other ways of doing that, but that's sort of the friendliest way to do it. Then we're printing the index, which is a variable that's iterating over that range. We're printing the character in trees that's available at that index. So this is the 0th index character in that string, the first index, second, third. So it carries on like that, but it's important to know that these indexes start at 0. It's a huge thing in programming, and it's where we'll make a lot of mistakes in the sort of early days where we sort of count up to a number incorrectly. It's also why, for example, this range 11 function only counts up to 10, because there are 11 numbers there, but it started counting at 0. So it's just one of those things that will click in your brain as you go through it. Then we're using Modulo 12 to loop around this list over and over again, instead of, basically, so I don't have to make like this big infinite trees thing. Because otherwise I'd have to I could manually just duplicate this 1,000 times, but that seems kind of silly. We could just sort of check the position modulo 12, and we don't actually have to care about how far it's moved across because it repeats. So we can kind of, instead of moving it, thousands of trees across, what we can do is just loop it around the same track over and over again, as if sort of as soon as you get to one side, you just appear immediately on the other side. So that will probably save us some work just using that modulo. And yet, we don't really need this code, but I was just checking my modulo was correct, which it is. Okay, so let's start. So it's not really enough that I have this first row. Obviously, we need to be able to. Actually, no. Let's say that it is. And instead of jumping into moving right and down, let's just try moving right, and let's see if we can deal with that. So def move right moves. I don't know, moves. So that's gonna, moves will be 3 in this example. So move right, and I'm gonna need a current position, and I'm gonna need a new position. So let's say current position, and we're going to want to return a new position, which in this case will just be the index as we move through. So I'm going to return 0 every time, And so what we can do here, we're going to move until we're at the end of the list, which isn't really going to happen. So let's just make like 10 fake moves for now. Move in range 10, and I'm going to move right. I've got our current position, which is going to be 0, because we're in that starting top left position, and I'm going to move 3. So what this is going to do is just return 0 every time anyway. I need to update that position as well, so we're going to say position equals 0. Later on this will probably be like an XY coordinate, but for now I'm just going to say position equals 0, and then position equals move right, which will return our new position, which for now is always 0. And then I'm going to print new position, and that's going to print position. And I could print, or I could do some weird, yeah, let's do some sort of friendly, let's do something that makes us like a friendly position. Print friendly. So this will be something just for us so we can see that things are working the way we expect. So that's going to take a row of trees. I'm regretting this name trees already. Let's call it row. And a current position. I don't need to say current position, just say position. And what this is going to do is it's going to take something like this, and it's going to return something like, I guess we could do our X and zeros, right, from the actual prompt. So what did they say? Zeros, where there was an open square, and X where it was a tree. So let's do that. So return with 0 where there was an open square, and X. Return 0, open square, and X tree. Okay, and that's, so we've got our row, we've got our position. We're going to do an if statement here, so if row position equals an empty square, then we're going to update row position to equal, oops, got to be a string as well, circle. This is our first else that we've used. So an if has to have sort of some Boolean condition at the end, and an else doesn't need it. So it uses, you know, if that if statement was false, then we go into this else statement. So if it wasn't a dot, we know safely that it was a tree. So we don't have to add any more logic in there. So we can set that row position to X, and then we can return row position. Oh no, just row. Row. Why is that complaining there? Invalid syntax. So in these have to be some sort of Boolean comparison or some sort of true or false value. So if you use 1 equals, that's an assignment. So that would overwrite the row position with a dot. In this case, we're now saying, is this row position equivalent to this dot? So that's a double equals for a Boolean condition there. Okay, so now I should be able to do print friendly, and I'm going to pass this our row, which is trees, and I need to pass it our current position, which is position. Lol. Row position, oh. String does not support item assignment. Interesting. So what I've tried to do there is just overwrite the character in the string, which I can't do. So I'm going to have to Google that. Python overwrite character in string. They got to replace. See, I assumed that string was a list, but apparently that's not allowed. Gosh, that's pretty. I don't like that. Fast method. I like fast method. Oh. Maybe I I don't like fast method, but let's see. So it's a little bit more complicated, but we're going to have to use the position. So count up to the position, and this is position plus 1. So let's see if that works. But row, row. Doesn't look like it, but have I actually updated anything? Row position plus C. No, so I need to say row equals row position. Okay, so that's kind of worked. So let's try returning a 1 here just so it moves a bit to the right. Yeah, okay, that looks good. Right, I'm aware I'm going to have to explain this as well, because that is also some magic, which is not good, especially when I'm trying to explain aspects of Python. So let's see how we do. And I'm going to use this comment as sort of a documentation there. Okay, so move right, we don't actually want to move right 1. We want to make use of our moves right, so that needs to be current position plus moves. That's not everything we need to do, because we need to make use of that modulo, but for now let's do that, because we should see a few successful moves before then. Why is that complaining? I thought I fixed it. Oh, I didn't delete the line. Okay, so now we're not updating our current position, it looks like. Current position is always 0, because here I don't actually use position, so that should do it. Okay, and then it breaks, but it breaks because we're actually leaving that sort of list of 11 that we need, so that's why we need this modulo. And now I've lost the actual, no I haven't, I think that's good. Okay, so all I need to do here is add a modulo 12, and that should loop it. Maybe that should loop it around together. There we go. That doesn't quite look right, does it? So something's going a bit wrong on the looping. Right, 3 movements from here should be 1, 2, 3. It should be 1 more across. But it's good that we see that now. So what's going on there? Three, 6. It's modulo 12. Should it be modulo 12? I think so. 1, 2, 3, 4, 5, 6. Yeah, it should be. I mean, this one is moving correctly from here. That's definitely moved 3 across. Is there an extra? Am I? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11. Why am I using 12? Why am I using 12? Should it not be 12? Should this be 11, modulo 11? I'm using 11 everywhere else. That's not right either though, you shouldn't be there. And now there's a space. Oh no, it's okay. So that 10 has just shifted it across, but that looks alright. So that goes 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Yeah, I'm somewhat happy with that. It's a little bit weird. Right, what have I just done that I didn't explain? So all of this stuff. Right, what we've got here is we've got something called slicing notation or slice notation. So if you have a string, let's put 1, 2, 3, 4, 5, 6. I should keep that in a variable. X equals 1, 2, 3, 4, 5, 6. Then using these square brackets, we can use something called slice notation with a colon. So if we just do a colon there, it gets everything in the entire string, which isn't too useful. But what we can do is we can set a starting position and a point it counts up to. So if I say like 0 to 10, it'll count the whole thing from the 0th position up to the 10th position. But if I do something like just a 2 here, it'll only return those first 2 characters. So again, these are 0 indexed. So it's counting up to the 2nd index. So 0, 1, 2. And then we can do the same thing from the other side. So if I do 1, it'll skip the first character. So all I'm doing over here is I'm saying count up to our current position, add that 0, that circle, or that X, sorry, and then go 1 past our current position and put those strings together. So when we're adding this X in, what it's doing is going through the original string, getting that first bit, adding in an X, and then skipping a character and printing the rest of the string. So it's a little bit messy, but it does the job. And that's why I'm making sure I'm printing out loads of stuff here, because even though I'm not even close to my answer yet, if I don't do this now, it's going to be a nightmare later on. So cool, we're making some moves. We can only move right, so that's not great. At some point we're going to need to start thinking about moving down the board. So we've got our moves right, which is cool. We need to modify moves right so that it's just a move now, and that needs to be an XY coordinate instead. So instead of 3, let's keep it simple. Let's give it 3, 0, and we're going to say this is move right and move down. And at the moment, all we're dealing with is that move right, but I'm just going to sort of slowly shift the code over to something that can deal with 2 dimensions. Oh no. Yes, because I changed my function name. This is going to happen. Okay, I can't use that for moves in. Okay, cool. Right, okay, we've got, so that's still working. Now I can move down as well, although moving down will do nothing if we pass that in, but at least we're dealing with it. So now let's start looking at, we could print, this needs to print for all of the trees, and our trees variable needs to hold everything. So it might be a good time, I could sort of write this in myself, but I don't think that's going to be a good idea. So I'm going to just start using this as a file. So if we go into this files menu, inputs.txt, and basically the same code we've used every week. We're going to split this into a list of strings. Read file line by line Python. I'm going to Google this every day. We always need to do this in admin of code, and I never remember it. But that's okay, because that's just how programming works. So now I'm going to have trees. This is going to break just about everything. So we don't care about that, and we're looking for this as our answer. Our answer is that. I'm not going to worry about the modulo stuff anymore, and I don't need this line anymore. That doesn't do anything anyway. So let's get rid of that. So now we have trees. It's probably going to break something because now we have a list of strings instead of just a string. So we need to look for where we actually start using those trees, which is here. For now, I'm going to say trees 0. So that should work exactly the same. Doesn't. This needs to be our file name, inputs.txt. Yeah. Okay, cool. So that still looks the same to me. So what we really want here is we need to print out the whole forest, just to make sure that I'm actually reading it in and sort of visualizing it the way I expect. So print forest, and let's just take a trees object there. So that's going to be our list of strings, and all we're going to do is we're going to iterate over for row in trees, and we're going to print row. So that's just a nice helper function to get us started here. So I'm going to print forest, trees. Why are you complaining? Because I've not got trees yet. This is probably the first thing we need to run. So this rule runs in order, so that's why I have to have these functions defined before I call them. So now we print our whole forest. That looks pretty good to me. Does that look like this? Yeah, I like it. And I'm going to keep that comment. Cool. So we print our forest, and now we move through the first row. And It'd be good to print out each version of this forest as we go, so we can sort of make use of our print-friendly row anyway. So let's see if we can add the starting position here. So we know that's going to be denoted with a... Oh, do we know that the starting position is in a tree? Yes. So you know it's going to be denoted with a circle. So let's see if we can do that first move here. And then we can sort of replace it in our forest. So how are we going to do that? I guess we're going to keep using this moves thing. Will we ever be in the same row again? I'm very nervous about, again, the second part of this program where we're going to have to... I feel like for now, you know, we've assumed that we're moving right 3 and down 1, but it's probably going to say, you know, given that you can move in any, you know, any gradient, what's the most efficient route down or something like that. So that's why I'm trying not to like hard code this 3 and down 1. But yeah, let's try and get this first move in. So let's assume we're only going to do this. Let's not even do any moves. How about that? That sounds cool. So our start position now, I'm going to refer to with an XY variable here. So that will be X and Y, where X is the number of moves from the left and Y is the number of moves from the top. And this will be useful, I think. Position equals 0, 0, so we want to make a move. I guess we don't need to make a move. We could probably just... No, let's make a move. Let's not do the first. Yeah, they don't denote the first one, so let's not do it. But let's just see what happens when we try and make one move. So I'm going to make a new move, and we're going to move 3, 0 to start with. And I'm going to try and update the trees array so I know which row I'm in. So I'm going to go trees 0 is now going to be equal to our print friendly row. And that's going to be, the row is 0. Ooh, the row isn't 0 anymore, the row is trees 0. And the position is going to be our new position, which we've already got. Then I'm going to print again, print forest round brackets. Okay. Oof. So it's having trouble doing current position plus move right. Current position, because our position is now an XY coordinate, so we need the first element of that XY coordinate. Okay. Print forest is now missing a requirement. Print forest because I didn't give it the trees array. Okay, so we've got our first move done. Let's add just an extra empty row after that. Print. Just to like make it clear that we're in between two forests. Okay, so we've done one move. We've got this starting position, which is always going to be the same. And we're basically going to do this until we hit the bottom of our blah, 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 trees. Yeah, I'm going to deal with that slightly later. I'm just going to say for number in range 10. Let's not do 10 moves, let's do 3 moves. Then I'm going to make a move, update that move position, overwrite the first line of the trees, which we don't want to do just yet, but we'll have to use our position Y here to know which one we're updating. But what this should do is we'll basically do like a bunch of X's or O's. Oh. Int object is not subscriptable. What on earth is that talking about current position 0, because I'm now passing it just an x coordinate, I think. No? What did I just change? Because that's probably where I've broken it. For number in here. Did I indent that? Current position, move right. Making a move, I'm giving it the whole position. And I'm returning just the x position, which is our problem. So this needs to be... Okay, so we're basically dealing with the outcome of trying to move this step by step to a 2D array. 2D array? Not 2D array. Yeah, 2D array. Okay. If row position is equal to a dot, string indices must be integers. So this is where this one needs to be. Yeah, this position will always be an x. So we just need, I feel like I'm going to regret typing this bit, but I think we just need an x there. I'm definitely going to forget I've done that though. I'm just thinking, can I make some of this easier for myself somehow? Like I've got some kind of spooky names like trees 0, position 0 that are kind of losing their meaning. But here we got our 3 moves. So we move 3, we hit a tree, we move 3, we don't hit a tree, we move 3, we don't hit a tree. And if we go over to 4, we'll see that that loops around, hopefully. Yeah. So we see there we move and we don't hit a tree. So now we're getting somewhere, but now we need to deal with moving down. So instead of worrying about, I'm going to use another pretend example that I'm only moving right 0 and I'm moving 1 down, and then we can deal with that without worrying about right. So you can see we stay in the same position. That's because we've not dealt with that case yet. So that's going to add to move right, and move down is going to become current position 1, that's our y coordinate, plus move down. That's not going to do anything to our prints though, because we also haven't dealt with that in our print statements. So trees, we always assume it's 0, but it's not actually going to be 0 now, it's going to be position 1, and here position 1. Ooh. Okay, so it's moving diagonally, which is not good, but our print's working, which is good. So let's see, why is it printing everything twice now? Did I tell it to do that? Is it adding rows? Is it duplicating rows? Let's slow that down a bit. Let's assume it's always 0. Oh, let me clear everything as well. Okay, that was okay. So now I want to say trees. This is where I'm breaking it then, which is good to know. Trees, position 1, which should get the y coordinate, which will refer to the rows, equals print friendly trees. I don't need to update position. I need to update this one to be position 1. Boom. Okay, so now we're moving straight down, and that's still working, which is amazing. More than I expected. Now this is becoming one heck of a line, so let's do something about that. So I might just say, in here I'm just going to say x equals position 0, y equals position 1. And then at least I can use it like this, and it might make this make a bit more sense to me. Position 0 is x. So now we can see print friendly is getting a row, it's getting an x coordinate, which is the position we're currently in, and that's what we're checking against. So that looks a bit nicer to me now. Update our position. Okay, so I think we might be in a place to try moving diagonally. That looks very promising. And it collides with a tree. Okay, I'm feeling good about this now. So what should we do next? We need to basically do it until we hit the bottom of the screen instead of doing it for a fixed range here. So I can't just say we're going to move 10 times because we don't. I guess we could figure that out, but I'm not going to do that. So basically I want to say while position Y, this is going to go outside the array, which could be a problem, but let's see, while position Y, I can't use position 1, is less than the length of our trees list. So if I print length trees here, we get 11, and position 1 will be whatever position we're at. So at that point it should be 0, 1, 2, 3, 4, 5. So 5 is less than 11, so it should carry on. Oh, we need a colon here as well, and we need to indent everything below it. Well, we're not going to do that, so we don't need to indent it again. Yep, it goes out of range, which is kind of what I expected, so we need to make sure it's, especially if we're moving more than 1, for example, if we're moving 2 at a time, we would go potentially out of range and that would break things. So we need to make sure that we are stopping at the right time. Shall I just do -1? Will that work? At least then it doesn't complain. Okay. Right, now what we need to do is take this solution we've got and we need to calculate how many trees we hit. Which should be 7 in that test case, right? So let's test it instead of moving. So this should hit 7 now. 1, 2, 3, 4, 5, 6, 7. Cool. And we can just increment. We can basically have a global counter that will increment every time we find an X here. Another solution, we could just like search through this list and count all the X's, but that seems kind of silly since we know when we're adding them. And this whole visual side of stuff is not an essential part of our code at all. It's just me doing it for some reason. So I'm not going to worry about that now. Let's just do a global counter. I think that's going to make sense. So number of trees equals 0. And then in here I'm going to say number of trees equals number of trees plus 1. Wow, got some Christmas underlines. Yep, didn't use it. Okay, and then in our print friendly, instead of printing that line, how about we print trees so far, and then that can be comma number of trees. Oh no. Number of trees referenced before assignment, but I made a number of trees out here. Local variable number of trees referenced before assignment. Because here it's referenced before. So I can move this. Oh, yeah. This needs to go up here, that's all. Now where's it complaining about? Number of trees. It's only those ones. Number of trees referenced before assignment. Am I calling it anywhere else? Perhaps within this scope this is a new variable then. Which means I can't do it like that. Local variable. So how do I distinguish it from a global variable, or can I not? So there's this notion that variables defined within functions are only accessible within those functions. So when we say number of trees is equal to something, it's perhaps making a new variable in here instead of this variable out here. So I can check it if I type print number of trees, it'll probably just error. Whereas I'm looking for it to print 0, which it doesn't do. So this is not, it's not happy on this row. Especially now, look, it's complaining about line 19 specifically. Oh, okay, something I didn't know, you can explicitly set something as global. No, I can't. Did I do that wrong? Global num. I've never used this before, so I'm not sure it's a good thing to do, but let's see. Hey, what gives here? Global num. Do not use global variables in this way. Okay. Yeah, I feel like I'm teaching a bad pattern here, so I'm going to not do it. What can I do instead to make this work? Number of trees. I guess when I return this print friendly, I'm just going to check if there's an X in trees Y. This might punish me later, but check X in new row. So I'm literally just going to do trees Y. I think there's a find function, string find. Oops. Call that on the string. Let's see, yeah, string.find. So trees y dot find x, and what this will do is return the index of that x, and if it can't find it, it'll be -1. So let's see if there's an example row. So here you go. Here's an example one where we didn't find a tree. Oh wait, is that printing for the next one? So it didn't find one there. Yeah, okay. So if that is not equal to -1, that means that we've not found one, so we have found a tree. So that should say true if we find one. So false is not false. We don't find a tree. True, we do find a tree. So we should be able to use this as our counter. So here I'm going to go number of trees equals 0, and then I'm going to say number of trees equals number of trees plus, let's say tree found equals this. I wonder if looks a bit, doesn't look great, does it? But let's see. Number of trees equals number of trees plus 1. No, it's not, plus tree found. And then I can print number of trees, print, do what I wanted to do before. Number of trees found so far. Number of trees. Cool, so it does end on 7, doesn't always increment, so that's looking okay. And I basically, yeah, that's all good. So I basically can't print the forest with the real test case because it's going to be huge. But let's give it a go. So we found 102 trees, and we didn't always find a new tree, so that's looking okay. Let's give it a go. 102. Oh no. That's not good, is it? So something is not right there. But what could it be? So it is still moving 3 and 1. I am moving right 3 and down 1, aren't I? Maybe I should print it and just debug it. I think that's going to be potentially a problem, but let's have a look and see what it's doing. Yeah, it's going to be a problem. Let's stop it early, and then we can just have a look through. Oh, I know exactly what this is. So what we can see here is that it's rotating around, but we never actually updated that modulo to not use the 11, which was the length of the original one. So it's just looping around in the start. Good thing we wrote that print tree function. So I'm looking for my evil 11s here. 11. That's the only one. So what we can actually do here is the length of trees, any tree row. And because that's global, we should be able to access it there. So now when we run it, did I not get rid of print? I didn't. That's bad. Okay. Ooh. Length trees. Yeah, I didn't close something there. Didn't close my length function. Okay, another number. Let's look. So 214. I'm going to print the trees just so we can do a visual check. I'm not going to print them all though. So what have we got? 10 trees, and we can see it's moving across. I should let it. I'm going to let it run a little bit longer just so we can see if it loops around to the next page. Yeah, that looks better. Wow, this one's really hard. Day 3. I don't know if they get harder as they go on. I normally give up a few days in, so let's see how this goes. But I'm aiming to spend an hour on each challenge. There we go, check this out. Another star coin unlocked. That's the correct answer, everybody. Good work. I can't believe it. 1 gold star. So now we can have a look at the next part of the challenge. I've only got like 6 minutes left to beat this in an hour. So I'm not sure how loud that music's going to be, so I'm going to go back to this. Right. So time to check the rest of the slopes. You need to minimize the probability of sudden arboreal stop after all. Determine the number of trees you would encounter if for each of the following slopes you start at the top left corner and traverse the map all the way to the bottom. In the above example, these slopes would find 2, 7, 3, 4, and 2 trees. So this is the modification I expected, that we would have different slopes, so I'm not too nervous about this. I need to test these 5 only, which also isn't too bad. So really I can just kind of do this manually. I'm not too... Literally I've got this loop here, so I can just call this loop over and over again, modifying this movement. So it doesn't sound too bad, so we're gonna... I might not even test this, as I say, we've got like 5 minutes left. So what I'll probably do is wrap this up. I'm going to need to reread in the trees each time as well. Make movements, and I'm just going to give it 1, 1. No, I'm not. I'm going to give it move X, move Y, and that's going to be there. Move X is going to be this, move Y is going to be this. I'm going to call this function make movements with 3 and 1, and we should get our score. What's that complaining about this time? Number of trees. I'm going to reset number of trees each time we run it. Ooh. Position, I need to reset each time we run it as well. Right. Don't need to print that, and I'm not going to print trees found so far, I'm just going to print at the end of the while loop. This should just give me the last one, trees found. Why is it printing? Did I still make it print the forest at the start? Yeah. So let's tidy that up, tidy this up. Now we should just get one line when I run it. Trees found so far. If I run the next one, I feel like it's gonna might not reset. Like I've overwritten my trees variable, so I might have to read in the trees each time. But let's just see, we can test that by running them both and seeing if they change when we run them in the other order. And they do. So yeah, something's not right there, but I think it's because if I print our forest, we're gonna see, I can't really do that because it's gonna take too long. We can print our forest outside of this function, so here and here, and we'll probably see on the second forest print, in fact let's not do that first one, on the second forest print we'll still have the root from the first one, so one. Yeah, that looks okay. Yeah, we can see here, look, when we run our 3.1, we still have that original root going through. So all we need to do here is basically not rewrite the trees each time. So when we do this, we can basically call this at the start of each. So if we do this, is that going to make me upset? Trees is... Maybe I'll do both. Maybe I'll leave that there, but I'll also overwrite it each time. Or I can have an original trees original, and then that can be overwritten by trees original there, and then in here we just go trees equals trees original, and that will overwrite. Trees is not defined by 47. Print forest trees, yeah, because it doesn't exist anymore, that's okay. Am I not making a copy? Copy list Python by value. That's my 1 hour warning, but we're so close. So Python. So this is actually copying the whole, it's not copying the list, it's just making a reference to the same list. So this little hack just makes us make a copy of the entire list. So really sorry, because I feel like, I know this is aimed at low level stuff, but yeah, this is really pushing what I can do. So let's see what we've got here. Just try and get an answer at least. 1, 3, 5, make movements. 7, 1, and 1, 2. I really hope this is correct, otherwise I'm going to be very upset. Right. So here are our answers, and I don't know how lazy I'm feeling. I might just try typing them in. 94 times 214 times 99 times 91 times 46. That's our answer. Oops. I pasted make movements in. That's REPL's fault. Gonna have to wait a minute. I have to wait 47 seconds. Okay, well we can double check. Maybe we can use some of this time to check that we're confident in what we're seeing. So it doesn't look like there's more than one root happening in here, which is nice. It's moving down to, we can see all our different roots as well. So this is the 7 and 1. I'm pretty happy with those. 1 and 2 actually does worry me. Just checking that while loop actually finished correctly, but that's okay. because we made that assumption, remember, that we'd only move one at a time, but luckily that didn't sort of break our loop, it seems like. But yeah, that's, I think, that's what we thought. Ladies and gentlemen, we've done it. 2 stars again, with only 2 minutes extra needed. I'm getting so close to saving my vacation. I got 6 star coins, and you need 44 more to go. Amazing. Thank you very much for watching. I'll send all that stuff in the Twitch chat, and I'll put it in the YouTube links as well. Thank you very much for joining me, viewers. Roll that outro screen. Thanks for watching.